Welcome to Mavens of Data. This week we're speaking with Chris Bruehl, lead Python instructor at Maven Analytics. Chris shared all about what it takes to get a data science job in 2025, and we had a lively discussion about the realities of being in the role. I hope you enjoy this episode. Thank you so much, Chris, for joining. Before we dive in, for those who might not know you, give us a little background.
Yeah, absolutely. I started out I guess it really starts in high school. I took some econ courses in senior year of high school and just fell in love with that ability to, use data to understand the world in a meaningful way. And that led me to get a quantitative econ undergraduate degree. After, my first degree, I ended up working in supply chain management for 3 years. So definitely using numbers and data to optimize, global shipping processes, e-commerce shipments, et cetera. But I was a little bit more operational role. And, I found that my ability to work through large amounts of data, even in Excel, was a bit poor. So I ended up going back to school to get a master's degree in analytics at NC State. And from there, I kind of graduated to a data scientist role, primarily working in the insurance industry. I started out in the insurance industry working on optimizing call center performance using predictive modeling, as well as e-commerce, website lead conversion. So if somebody came to our site and didn't purchase an insurance policy, we'd figure out the most efficient way to route them.
Get them back.
Exactly. And then spent a little bit of time in the product world before transitioning into fraud detection, which was a really fun job. We were just talking off call about that. And then during the pandemic, moved to San Francisco and had 2 offers on the table. One was with Meta to do data science, and one was to become a data science instructor at a boot camp in downtown San Francisco. This was a little bit of a sliding doors moment in my career. Ultimately, I made the decision because I didn't want to commute from San Francisco down south, which would be an hour and a half each way. Of course, the first day I started, we went fully remote because of the pandemic. So that factor was a bit different, but it's been an amazing journey. I taught at a data science boot camp for about 2.5 years before coming here to Maven, where I've built out both our Python for Analyst curriculum, worked on the data science curriculum, and then a sprinkling of other courses. And now I'm working on some internal data science stuff here as we, start to scale and really try to optimize our own operations. So it's been an awesome journey, and data science has been there for the last 10 years for me.
Awesome. Yeah, no. And so it sounds like you have a nice big look at the whole field to be able to share with us. So if you could give us a snapshot of what data science looks like in 25, the landscape, how would you explain that?
Yeah, I think no matter when you take the snapshot, it's really hard to put a finger on what data science is or what the biggest focus is. But I would say, even today, data science is really about using your technical skills and your critical thinking to design experiments to optimize business processes. Currently in 2025, we're seeing a lot more implementation and tuning of LLMs. So whether that's building chatbots for your internal company, but it's still very diverse. So, the bread and butter and probably the biggest portion of data science is still building predictive models to try to optimize whether it's something like product conversion, detect fraud, and thinking critically about how to measure that and optimize those processes by working with stakeholders within your company. But still to this day, right, the fundamental skills are going to be SQL. I would say learn that first. Statistics, you need a strong ability to run these tests and determine, is this better than that, right? So, and those are like stats 101, concepts oftentimes. And then, obviously Python to help implement and automate your programs. And then we can get more specific and more advanced if we leverage tools like Databricks and Spark, as well as I think a lot of the MLOps tools that are in your book. But fundamentally, it's really about critically thinking and using statistical methods to measure whether or not the changes you're proposing impact the business.
Yeah, no, I completely agree. And actually, anytime anyone asks me for a snapshot, I'm like, I don't believe any metrics, or you can like believe the metrics, but it's not the full picture of what's going on, because you're going to have people who are working with data and CSVs, and you're going to have people that are building real-time apps. And even the, the hypothesis testing and the statistics, it's so big and it's so useful, and it comes back in ways that like, it's just sort of always necessary. But at the same time, I feel like I saw a lot more hypothesis tests years ago. And then I feel like now it's likely that a company may have hired a vendor and implemented a tool so that they're able to run and get these analysis. And you still need somebody who understands what's going on to be able to interpret them. But it's not the same way as like, there were years where that was maybe 60% of my job was setting up and running tests.
Right. Yeah.
Yeah.
And,
so from your perspective, sorry.
Oh, go ahead.
No, go ahead. I mean, I'm leading right into
you're
where I think you're going, but like how have you seen data science change over the last 5 to 10 years?
Yeah. I mean, it's been a whirlwind, and I suspect it always will be. When when I started out, right, like models like XGBoost and, random forest and all these tree-based models were just getting up to speed. Just like we've seen with the evolution of AI in the last 5 years, right? There's this kind of convergence of technical knowledge, hardware performance, et cetera, that have all led to these just kind of hockey stick, like exponential growth in our ability to crunch numbers. So I think like, in that sense, like the tools or the models that you're working with, have gotten more and more advanced very frequently. Like our ability to work with big data is significant. When I was in grad school, we were taught Hadoop, and then 2 years later, that was just blown out of the water by Spark, right?
Yep.
And so the cutting edge will always be the cutting edge. But on the other hand, what hasn't changed is like the ability to think critically about a problem, understand how to define and measure, the impacts that you're trying to make to the business. And really like that thought process will serve you well, I think in this field consistently, right? We're data scientists. We're thinking about how to quantify the impacts in a concrete way of changes to the business so that it improves. We want to move this business forward by using data to do so. So it's like, on the one hand, the tech stack that like, I started out with SAS as well, which was like,
me too.
Yeah. And it was like SAS, and then R was kind of like the hot thing. And then Python just became, especially once big tech adopted it, the de facto language of the industry. So it's like the tools are always going to evolve, and like, we'll always have to continue to educate ourselves on what the cutting edge models and like are. But the same time, the mindset has always been the same, which is pretty cool in my view.
Yeah. No, I was wearing my our studio shirt yesterday, and I was like, ooh, this almost feels a little like vintage. But so, right, you were talking about like tools and models and stuff. What makes a good data science these days?
Yeah,
What's
I mean,
most important?
I think it's the ability to like, again, like when you're a junior data scientist, you're often just given a problem to monitor, like that a data scientist has set up. But it's really the ability to say, hey, like, how do I measure this thing that I'm trying to improve, right? When we're building a model, like, how do I define this 1 and 0? And that often involves talking to a lot of stakeholders in the business, really deeply understanding a problem. And only then can you really define the metric that you're trying to optimize. And it feels very trivial, especially when we take courses, right? Like, because we're often given these binary columns. But on the job, we have to define those, and we have to really think about like, what is the business? Like, we're trying to optimize revenue, right? And I'm working on a product. What is the subset of the population that I'm working with, and how do I how do I design these experiments? And I think that's like the most important thing. So having that, I think Chris Dutton talks about the analyst trifecta, which is a combination of technical skills, communication skills, and critical thinking / like domain knowledge. And I think that truly is the data scientist trifecta as well. The biggest difference is that we bring this additional statistical and experimental lens into these business problems and have a little bit more, I guess, technical horsepower to do that.
No, absolutely agree. And I feel like when you look across like social media and stuff, we spend a lot of time talking about models, and the models feel really sexy. And I remember, 12 years ago when I was building models in industry, they were very like artisan, right? I was looking for, when do I need a transformation? How am I going to think about these variables and like hand select them? And then in a lot of ways, that has changed, where like you mentioned XGBoost, and it's not that, there are certainly going to be areas where you're going to do more manual, but in a lot of ways, modeling has gotten a lot easier.
Yeah.
And like you said, with the, you mentioned data and stakeholders, right? Like the thing that hasn't gotten much easier is, well, I mean, it has in certain ways, because like the libraries are available with functions that are available to do a lot of the data manipulation that we need, but the data is still like a big piece of the lift. And so when you think about who's working on what and what different roles are doing, these different types of data functions in the organization, sort of how do you think about defining those roles and where they sit and what they do?
Yeah, I think it's interesting because like data science is sort of in some ways like a jack of all trades when it comes to machine learning engineering, when it comes to data engineering, when it comes to analytics roles. But yeah, analysts are typically going to be a little bit more focused on backwards looking metrics, reporting. They'll often dive into, they might touch on the causal inference, like, okay, we changed the product 3 months ago and we saw a decline in users, and like here's sort of the split, or here's sort of the change that we saw. Whereas like data scientists are going to be saying, if we make this change, what's going to happen and how do we measure whether there was an impact there. And so like a data scientist role might not involve modeling at all. It might really be focused on A/B testing and statistical inference. Or they might be implementing a model. I would say like the ML engineer, if we look at the Venn diagram, like, yeah, I wish I had a visual here, but like data scientists will typically scope a problem by doing some analyst work, understanding the business problem, and then build a model that, ideally optimizes some process. An ML engineer is typically working at a much larger scale or in a much higher performance environment. Like they're really focused on these very highly automated models and frameworks that are crunching like large volumes of data. And so the data scientist oftentimes kind of sits in the middle of those two roles. They need to understand this problem, and they might build the first iteration of a model that then a machine learning engineer takes and blows up in terms of scale. And then, the data engineer is like the atlas of all of this that holds us all on their back and makes sure that we have the data in the right time, velocity, quality, et cetera. And I always tell people, whether they're an analyst or data scientist, when you join a company, like make sure to build a good rapport with your data engineers, because they have a lot of, they usually have tons of tickets on their plates. And if you don't have a good relationship with them, that you might find yourself being deprioritized. But yeah, if they like you, you might find that your stuff gets a little bit more prioritized, and your data pipelines will be performant enough to get you off the ground more quickly.
Yeah, no, I remember in one of my first roles, people were like, if you can bring cookies. It was like, It was like not a joke. Like you could bring them cookies. And so if somebody was looking to break into data science right now, and right, there's like crossover and all these things too. I had analyst roles where I did get to the opportunity to build models, but it was very sparse. Like that certainly wasn't my job, and I wasn't allowed to put anything in production. Not that I would have been able to even put anything in production. Like that wasn't in my skill set at the time. And so, everything can look a little different everywhere. But if somebody is looking to get a data scientist role, what type of skills would you tell them to focus on?
Yeah, I would say, get a good foundation in statistics. Make sure that you understand the basics of hypothesis testing, distributions, probability, et cetera. Those are, not only, just going to be a job requirement, but that's going to inform how you think about a lot of problems, right? And that'll come across in interviews. So really having a solid statistical foundation allows you to speak the language of data science. And in terms of, technical skills, there's just this ever expanding universe of tools that we can dive into, but I would still say SQL is the language of databases. Your data lives there. So if you are an analyst and you've learned that, that's like a great step forward because typically before we can put together a tidy modeling data set, we're still pulling things out of databases. And then Python is going to be a very important technical skill. On top of that, right, like, about when you start learning Python, maybe you have a foundation in statistics, you've got SQL. That's when you would jump into a path like the data science and Python track where you're learning about like the primary modeling algorithms. And again, I think it's really because these fields are evolving so quickly, it's a little bit less important, I think, today more than ever to be a master of understanding the optimization functions behind logistic regression or stochastic gradient descent. Like those are still nice to know, like, but know how, like, understanding like classification metrics or regression metrics and understanding really what these models are, how to use these tools and when to use them is a much more valuable skill set, right? Like we have a tool belt as data scientists and, we can always add tools, but the fundamental tools we need are statistical analysis, data retrieval, data manipulation, and modeling, right? And so the scikit-learn library in Python is still great. There are definitely more advanced ones out there. But having the ability, like, so I guess to summarize, I'm kind of rambling, but like statistics,
I ramble too.
data manipulation, so SQL and Python, and then model training and evaluation with a library like scikit-learn would be the first kind of 4 pillars there. So it is a little bit longer road than getting up to speed with analytics, but it's that's what I would say.
Yeah, and for Python libraries, I'd probably add pandas and numpy because that's where you're going to do the majority of your data manipulation, which is a big piece of it, and that can get you very far. And then what I also love to say too is because when the data science programs started coming out in 2016, a lot of them didn't include time series analysis. But I've just never met a business that didn't want to know how things are doing over time.
Yes.
And I've also worked on a lot of teams where people didn't have that skill. So it's, as people are flooding into data science, that's obviously changing. There's going to be, other people you're working with that obviously have time series, but it's sometimes not everybody. And so it's like a really nice skill to have, even though it's not like a core skill, but.
Yeah, I know. And I always tell, like, I just wrote a piece about this, but like, if you're an analyst and you're like, data science isn't for me, or I'm not sure about data science, what I also recommend, like almost every data professional have like a decent understanding of regression and time series analysis, because those are often problems that are like, you'll see finance teams that are doing forecasting and they're using, relatively solid foundations like moving average models and having a bit more bells and whistles with like whether it's ARIMA or like Facebook profit, just to kind of assess the performance. Again, when we think about like data science skills, it's like there are new time series algorithms all the time, but what hasn't changed is like I'm using, mean absolute percentage error to measure this model and evaluate it. And it's gotten much easier to train. It's gotten much easier to train all of these models, but the evaluation and the thinking about like, I need to split, like instead of doing like a classic train test split, right? I have to do like a holdout window. It's a time series model, and understanding those techniques is going to carry through all of these. Yeah.
Right. And one of the changes too over the most recent years was like when in 2010, I was building econometric ARIMA models. and we do manual analysis of, using the coefficients to understand the variance from what we were expecting or what the impact was. And it was, the less interpretable models started coming out, and people were like, these are a black box. We can't use these to explain to our stakeholders. But there's also been a ton of research done in recent years in explainable AI. So you can get feature performance from these different models, and you can understand, what's really driving the differences. So again, it's starting to matter less which model you use, except you also need to take into consideration like stationarity and different things. And the statistics, then, if you're using a model that requires normality is your data. And so it's all that stuff. I just went on an absolute tangent.
No, that's great, because you got me thinking about, I actually lost my train of thought. No, I was really excited. It's time series is great. I was going to say, like, for my fraud role, like, talking about like black box versus explainable models. So I was building a fraud classification model, and like our stakeholders had never had a model behind this. They were using like just basic flags in the data that could be created by a business analyst. And I was so grateful that there were analysts that were like creating these flags, because it made building a model much easier. But the stakeholders were so afraid of a black box model, that I had to build a logistic regression first. But as soon as I did that one time and they saw that this modeling approach works, they're like, go nuts with random forest gradient boosting. We don't care anymore. We saw that these are more accurate and we understand sort of what's going on. And that's often the kind of dance you have to play, is get that initial buy-in and show some success with a modeling approach. And then you kind of get free reign a lot of the time.
Yes, no, there was a period of time where I'd build an interpretable model and a less interpretable model, and just like, hey, we're going to get trust, but we're going to put this better one in production. But here's how it's working and stuff like that. And then, it's great that we've had improvements in explainable AI, so you don't have to build two. But so right, and those are also opportunities where you're not always getting guidance from people on how you should go about this, or what, there's like a level of scrappiness in data science. Like, do you have thoughts on how important being able to just sort of like be scrappy and solution is, versus being in something that's like a little bit, following more rigorous process?
Oh yeah. I mean, like quick and dirty is often like the data scientist, like bread and butter. Like the first 2 years I was in a pretty stable role. And even then, like I watched the industry start to pass me by. So like, even if you do get into a situation where you are working with the same tools and the same algorithms and the same data all the time, you're sort of like, your career starts to feel like it's in jeopardy, because like you start to see like, people on LinkedIn or like other teams in your org starting to use more advanced tools. But the day will come when someone's like, hey, like we want you to try, maybe it's implementing an LLM in this area, or we want to move to Spark because we want to move to a real-time modeling system. And you may be able to avoid that once or twice, but ultimately you're gonna it's not gonna go well for you if you're not like, yep, I'll give it a try. And you're gonna be like slamming your head against your keyboard at times. But ultimately, like you'll find that you build this kind of muscle to kind of quickly research a new tool or new framework, get it into place. You're gonna learn a lot. You're gonna make a lot of mistakes with that. But ultimately you end up with this, like maybe it's a little bit messy prototype, maybe it's held together by Scotch tape, but you get a working concept, and then from there you get a refine. But yeah, just that ability to digest new tools and new concepts, and it sounds daunting, but again, it comes back to those kind of foundational tools that we discussed, in that thought process. It's actually very easy to absorb new tools, especially once you've done it once or twice.
Well, and doing POCs is the exciting part. It's going back and making it less brittle. That's
Yes, exactly. Then it's like, now make this work at a performance scale. Yeah. No, I mean.
Yeah. And so do you think that, right, like this being asked to do things that are maybe just new to you that you have to go and approach on your own. And with AutoML and LLMs, do you think that the expectations have shifted for entry-level analysts and data scientists?
That's tough. I mean, I haven't interviewed for a data science role in a little while. I mean, entry-level data science roles are kind of a crapshoot, so to speak, in terms of what the expectations are. But I do think that, I don't know. I mean, the hiring processes for these things are still like pretty convoluted at times. But I would say that you're still expected to have those like foundational skills and problem solving abilities, but probably a little bit less emphasis on like, the same deep level of algorithmic understanding that you used to, and a little bit more emphasis on like deployment, testing, all the things around implementation that used to be, maybe you'd be sending someone a CSV, but now you're focused more on ML ops, which I think you talk a lot about.
Yeah. No, and I love that you said crapshoot too, because, right, I think people go into an interview and they may get asked like absolutely incredibly difficult SQL questions that I personally, when I was a hiring manager, would never go in and expect somebody to know off the top of their head, right? And so if you don't do well in an interview, it's not necessarily you. If you do poorly in like 10 interviews, you might want to like reassess what's going on. But I've seen people do poorly and walk away and feel badly about themselves and feel like they're not good enough. And it's like, oh no, I mean, the interviewing process is also not perfect itself. Cycling back to what we were talking about. So, scrappiness, skills, foundation. Would you say somebody should look at learning more about LLMs and working with text data now, or is that something they should hold off on?
Yeah, I think given what I'm seeing, I think it's definitely a good idea to have some experience with text, and specifically like something like Hugging Face for sure. It's in a very weird place, but I would say like understanding how to tune an LLM and getting some understanding on that, because I think that's a growing area. But I don't quite know. I mean, I think this is one of those tools that's like, you're better off learning it now. I still think there's plenty of opportunity without, deep LLM knowledge or, implementation, but I think it's something you should probably be tinkering with as you start to think about your next role. But there's still plenty of roles that have nothing to do with, text analytics or LLMs, but it always behooves you to add these skills while you are comfortable in a role versus wait until the role that you really want requires it, and then you have an interview in 2 weeks or whatever.
Yeah, no, because again, it's so impossible to talk about data science as a whole, because depending on your team size, depending on the domain, depending on so much stuff, everything's different. But so if it's not necessarily LLMs, that people should necessarily focus on, how should people position themselves to stand out when they walk into an interview?
Yeah, I mean, I think more so, the data field in general, right? It's about demonstrating knowledge and demonstrating competency. And, frankly speaking, like having a degree in a data science related field, whether that's like advanced statistics or analytics or data science or, whatever, is always going to be a step up, right? But that isn't a requirement, but they do open more doors. So we should be candid about that. But I would say, like, if you are new to data science, like it's really going to behoove you to have some projects implemented on a GitHub somewhere or portfolio page to really demonstrate those skills, because anybody can say and anybody can take a data science course. but like the gap between, taking a course and following these very narrow boundaries versus actually going out and acquiring your own data, building a pipeline around that acquisition, and then tuning a model that impacts something in a meaningful way that you can show. Like showing is much better than telling in general, especially in the world of data. And I think for a data scientist, especially if you're trying to break in, it's absolutely critical, because otherwise people will just pass your resume over. But if you have a GitHub that somebody can look at and say, wow, this person wrote pretty good code and I liked how they think about this problem, that's going to give you a significant leg up for sure, compared if you're just applying cold. You'd have to be fairly lucky, I think.
Yeah. That's also why I love blogging. So I have a GitHub, but I figure if I'm sending my portfolio to a hiring manager, I can't tell how technical they're going to be, right? So obviously there's going to be some people that'll go in there and read it, and you should have a GitHub anyways, because it shows that you have code. But I like writing blog articles because I can go back and read my own notes, so that if I did a project 8 months ago, I actually remember the details of that project. I guess some people are good about writing a README. I'm not.
Yeah.
Mine are pretty lame.
Well, you can use an LLM for that now.
Yeah. Right. Yeah. 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 Nope. Thank you. Yep.
No, but yeah, I agree. I mean, and that brings up a good point too. It's like there's the stage of applying, and again, like having something that people can comb through. But then there's the stage of interviewing. And like, as someone who's worked in data science, I get to talk about some of the cool things that I've done on the job. And that makes me look like I might know what I'm talking about, or I might have interesting ideas to bring to the table. But again, if you're new, right, having built several, complex projects above and beyond, something that, the Titanic data set, right? That will also give you more fodder, because what people are really looking for in these interviews is like how you think. Like, if I give you a problem on the job, are you going to approach it with the right, data science methods, use the right metrics? And so having gone through that process yourself, I mean, you're going to learn a lot when you tackle this ambiguous problem on your own, but then being able to communicate the decisions that you made throughout that process are going to inform a lot about how you think. And like, it's okay to be humble. Like, someone might push back and say like, oh, why didn't you use F1 score instead of accuracy? But those are great conversations. And you can say, yeah, like, good, that I should have. And then you can talk about why, or whatever the case. But all of those things are great fodder for that whole stage of the process.
Yeah, actually, I've had that exact conversation. I used logistic regression for a retention model, and I had an interview at Kronos, and they were like, why didn't you use XGBoost? And I was like, well, I did this project like a year and a half after it came out. I wasn't aware it existed yet, but I probably would have used it now,
Yeah.
And those type of, but at least like I was aware that XGBoost existed now. I was right, like all the conversation you have. And in terms of portfolio projects, I like absolutely light up when I talk about the school bus detector. I have a number of projects that I have done in my past that, like, if I get an opportunity to talk about them, like, you're going to see my passion for working with data. And I think that is also really important too, to like just shine in that way.
Yeah. And like on this the other tip that I give people too, is like, when you're building a portfolio, like, it's perfectly fine to go grab some CSVs from Kaggle for one or two of your projects. But I would absolutely say at least have one project where you roll your own. You're defining what I had a colleague, for example, at a job, and he wasn't doing this for interviewing. He was just like a giga data nerd, but he scraped Craigslist ads within a 100-mile radius for trucks because he wanted to buy a truck. And then he built a regression model, basically estimating the price of these based on the mileage, how old it was, et cetera, the models. And he found the biggest delta, the biggest residual. So what was the best value by looking at his model predicted that trucks should cost $10,000. And he found one that was $7,000. And lo and behold, it was an amazing deal. Best deal you could find in 100 miles. And he put this together, right? And that's the kind of project that, people are like, wow, like they're scrappy. They probably had to learn web scraping. They had to automate some process here to continue to pull new listings. They used a metric and then it had an impact. And I'm not saying that everyone's going to have a project where you're really like decision making, but it's that kind of thinking, get that data together and building, defining that problem yourself after you've done a few maybe more guided projects. That's going to give you the most opportunity to really set yourself apart.
Yeah, actually, a couple weeks ago, I built a music similarity search app. I was looking
Nice.
for a competition dance song for my daughter, and I didn't like the apps that were available, and they all used cosine similarity. So I was like, I'm going to build one and use the dot product. And so, it was my first time working with the Spotify API. It was like the simplest radio app. I'm like not even that good at this stuff. Like being able to get code from ChatGPT really does make such a difference. If you are going to like put the time and effort in, you can work with a data type that you're not familiar with. You can try something new, and it's a different ball game. And so, because it's a different ball game, how do you feel about like, is a data science degree required to get a data science job these days?
Yeah, I would say no, but if you're getting a degree, they often have relationships with employers in their area, right? So you're going to get more shots at interviews. And with data in general, right? Like a degree is a signal that you learned something, right? You had to go through a curriculum. And like, I don't necessarily, I've met plenty of data scientists who had no specific degree. But it is, I do want to communicate that it still can be a worthy investment because it does give you access to doors. Like there are often master's degree or PhD level requirements for jobs. So like, just know that not having a specialized degree, your pool of opportunities is going to be lower. The other path that I really like, and I think you kind of mentioned this, is if you are an analyst right now and you want to be a data scientist, like look within your company for people to partner with. Like I've known a couple of data scientists who were just really curious about this stuff, and they would talk to you, and maybe you move to a team that's adjacent to data science work, and you just kind of ask like, can you mentor me or you walk me through this process? And most people will be like, yeah, if you're doing your job at a reasonable level and you're friendly, like people love to talk about this and help you, and that can be much better because you don't have to prove yourself as an outsider. You're just getting mentored as an insider. And that can be a much more effective transition path a lot of the time.
No, that's so important because like, especially as more people come into data, who becomes even more important. And yeah, and the degree is still very important too, because it's just like, it's traditional, it signifies that you learned. But also I think as there's more people in data science who and having like a social media presence is going to become increasingly more important. Do you agree with that too? Social media?
Yeah, I think so. Yeah, I think it, it took me a little bit to get like involved in social media. Like I was lucky to get a job, but I do think, again, there's kind of two forms of networking. There's the sort of private, like, hey, like I'm messaging you, I'd love to talk or have a coffee. And I would say there are good ways to do that and bad ways to do that. But then there is that social media presence, like communicating your learning process. People will be like, wow, like Kristen has really learned a lot in the last 5 months. And I really was excited to see her most recent project. And that can be fodder for, you establish credibility, you establish a personality. These are both two things you're trying to do in an interview process. So you kind of, I think you're increasing your odds in a significant way. And then of course, if someone interesting follows you because you posted, like a hiring manager at Google or a company in your area, like, hey, you want to grab coffee, right? And then that can be an amazing way to kind of short circuit that, just mess of an online application process.
Yeah, I think every role I've had since 2019 has been through somebody who reached out on social media. Okay, so what are some common mistakes you see aspiring data scientists making right now?
Yeah, I think the biggest one, and we sort of touched on this a little bit, but it's being like hyper focused on the modeling itself. Modeling is, especially as an outsider, the sexiest part of the job. It's like, wow, like I'm building an algorithm that can predict things. But most data science work happens in problem definition, monitoring, implementation. And so again, when we think about portfolios or how you're communicating things, like just make sure that you are looking very well rounded in the sense that you have communication skills, that you like have SQL, right? Like you could be the best PyTorch, or like you could be amazing with LLMs, but if you can't write SQL and you go into an interview, like you're not going to get the job, right? So like some of those, that kind of pyramid of skills, like modeling is very high up here, I would say.
Yep.
It's very important, but like don't neglect a lot of the foundational skills, which fortunately have a lot of overlap with other data roles too.
Okay, awesome. And just one more question. So Maven has a new course in NLP and LLMs. What inspired that, and how is it filling the current industry gap?
Yeah, so I wish Alice was here to really sell it. She's having an amazing summer off, and we all love her for that.
Tell us.
But yeah, no. But when we actually set out to build this course, like NLP was always in our roadmap for the data science path. But as we sat down to develop this course, we were just like, this field has changed a lot. And we still have traditional NLP, so things like tokenization and word to vec and spacey or whatever. But like you're sort of kidding yourself if you think that like something that you roll with a very limited data set is going to be better than a pre-trained GPT, like chat GPT for sentiment analysis or whatever. And so Alice put a lot of effort into we still teach that, but again, maybe not at quite the same depth or importance that it used to be, but we focus on how LLMs work and with a primer on deep learning. And then we show like a lot of amazing techniques that you can use for NLP work using LLMs. And so that's kind of a more forward-looking approach to this. We're trying to stay modern, right? Again, in a year, who knows? But we definitely wanted to make sure that we had a modern approach to these tools because it's really fun to upload a CSV of text and ask it to classify and comment. And it is these tools do an amazing job at this stuff.
I mean, I was having problems coding yesterday, and like I realized I can take screenshots.
Yes.
So it's like my code plus my error, and it's like I only noticed yesterday because before I was like, copying, pasting my errors or typing in my errors, and like now it's like, oh my God, I can just take a screenshot and put it over there. Wild. Okay. Getting into real questions, Diego asked a Maven question, so he goes first if you know the answer. He said, I noticed you have a course called Python for Data Analysis and Business Intelligence, which I'm taking as an intro to Python. And then Alice has a course, Python Data Science, Data Prep, and EDA. Could you go over the differences between the two courses? Which is more of an intro course?
Yeah, great question. So we have two different Python paths. One is Python for data analysis, and it starts with base Python. So that's the Python Foundations course you mentioned. That is like the fundamental syntax and building blocks of the Python language. What is a list? What is a tuple? How do I do basic arithmetic and string operations? And then define, custom functions. So that is the most foundational Python course we have. Python data science starts with basically an understanding that you have a little bit of pandas. So if you're completely new to Python, I would suggest taking the first two courses in our other Python track, which is base Python and then pandas. But data prep and EDA does also have a lot of pandas, but it's more focused on a lot of the functions and techniques that we need as data scientists, things like creating dummy variables or splitting our data, right? And so there's a little bit of there's definitely some overlap between my pandas course and Alice's data prep and EDA course. But hers is sort of a condensed version. There's more visualization specific to data science. But I would absolutely suggest if you're new to Python, taking Python Foundations. You could probably do okay going to the data prep and EDA course, but your pandas will be a little bit limited. You'll want to revisit that at the very least. So yeah.
All right, awesome. Jared asked, mentioning Python and SQL and further breaking down libraries like NumPy and Pandas, would PySpark, Seaborn for Data Viz, or JSON also be helpful?
Absolutely, yeah. So PySpark is, an amazing tool. And the great thing about it is that there's a lot of similarities with the Pandas language. So, I was actually telling somebody the other day, and a student asked, and I said, like, now you could probably have ChatGPT translate your Pandas code into PySpark pretty handily.
Pretty easily.
Yeah. It's still worth understanding the concepts and the differences and things like lazy evaluation, but PySpark is a very helpful skill. You'll encounter it a lot, if you use something like Databricks. And then we also do have a course on Seaborn for Data Viz. And I believe in that data prep for an EDA for Python, like in the data science track, there is some Seaborn for Data Viz, again, specifically to visualizations you'd use a lot as a data scientist. And then JSON, definitely worth knowing how to work with those files. You can kind of learn it as you need it. But yeah, the JSON library is super helpful. And again, I just had an internal project where I had to extract a bunch of JSONs, and ChatGPT was amazing for helping me like get really up to speed very quickly with like my specific level of nesting and like stupid things like it wasn't stored, so it wasn't stored with quotes, whatever. Like, yeah, super helpful there.
Reem has asked, based on your expertise, what important features should be included when developing personas or customer segmentation?
Oh boy. I mean, the cop out is it depends, right? But obviously, like thinking about like our business, you'll look at a few things like demographics. So is somebody currently employed or not? Are they a student?
Which is typically third-party purchased data, right? You haven't worked somewhere where they got that like.
Oh, we have. Yeah, we ask.
It's something that you purchase separately, and you got to like get buy-in for the company to go get it. But it's so important. Sorry, keep going.
No, yeah, we usually ask people, but yeah, third-party data is awesome too. But yeah, like. What's their tenure with the company, and then also it's kind of like demographics, like what do people tell you when they sign up, like what's their location, like a customer from the United States is going to look different than a customer from Japan, like a lot of the times, and then like what is their behavior in the app. So you can do segmentation like universally, or you can segment within these kind of families of data that you have. So we might like think about a persona of an app user differently than we think about a persona of somebody who signed up for free and maybe hasn't taken a course yet. Or you can kind of combine this and roll this all into one, depending on the problem you're trying to solve, right? So it is very much, it depends. But the fun thing about being a data scientist is you can chuck stuff into your segmentation model and see if it, adds noise or adds value. But I don't know if you have any other thoughts. Like I haven't personally done a ton of segmentation.
I just want to add one cute thought, right? So like try and get good about thinking about features that are relevant to your business.
Yes.
So I once did one, and it was a subscription business for an email marketing. And so I built a model to basically look at each customer's usage and tag them whether or not they had a seasonal business, right? So now then it's like, are we going to treat like, are people who are seasonal different from people who aren't seasonal? And of course, you're going to, chuck things just like Chris said, but so you're going to try and pull together everything that you can. But so Chris already covered most of the things, and a lot of it is the stuff that you already think about every day and you have access to. If you need to buy third-party demographic data, great. A lot of times in the like Axiom, Epsilon, those companies that sell data, sometimes they might have something. You go through the catalog that you realize is something that would be useful to you, maybe for a reason that isn't even necessarily like quickly intuitive. It might mean something else or whatever. And then also thinking about how you can build features that help you get at characteristics of these people that might also help you build those personas.
But yeah, very deep question.
Oh, this is a fun one, a little more light. Giovanni asked, what do you love and hate most about your role as a data scientist?
Yeah, that is a fun question. Yeah, hate might be a little bit of a strong word, but I will start with hate because, then we can end on a positive note. I think one of the toughest things about being a data scientist is you have to learn to live with like not having an impact sometimes. So
Yes.
you might like have this amazing idea for a model or a new feature or an experiment in your intuition. You sell people on it. And then you go to model it and you have like no lift. It doesn't mean anything. Your hypothesis was totally busted. And you're just like, then you have to, go talk about that. And you get better at that. But there's also the kind of the political aspect of impact as well. So you might actually have like an awesome model or an awesome idea, but other people in the other people in the company are uncomfortable with changing the process or, the techniques you're using, or some other team owns that specific thing and you're trying to kind of build a project that spans a few things and you might get shot down. And so like, if you are hungry and excited about tackling things, there are going to be moments of failure that, are because the data didn't prove anything out, or because, unfortunately you got shot down. And as somebody that is excited to do stuff like this, it can be very defeating, right? But on the other hand, I love the opportunity that I get to kind of like, think about ways to change the business. And when you get that satisfaction of, wow, like all I did was write like 50 lines of code and I like made the business a couple more $1 million. And I get to try and do that again tomorrow. And I get to think about the next place to have that impact. And it's like really, really fun when you get to see that. And so it's that double-edged sword of like, it's a little bit of a roller coaster because every project has different amounts of potential. And sometimes that potential isn't there.
Yeah, no, right. Because it's not just technical. You brought up the politics, and you do have to spend time safeguarding your career, and you can spend time on a project that isn't high visibility, isn't going to get you accolades at review time. And you have to be like defensive and think about these things in a way that I didn't realize when I started.
Yeah.
Yep.
I learned that lesson. I had a friend who like just found one variable and like it was just like a new project and it went nuts. And then I was on this thing like optimize this model that was already failing and like had no impact, and it was like so frustrating.
Yeah.
But yeah, it was a good time.
Are entry-level data scientists expected or encouraged to meet with stakeholders outside their team to clarify project needs, or are they typically kept laser-focused on a single technical task and interact with their data science managers?
Yeah, in my experience, it was sort of like a training wheels thing where it was like the first couple weeks or maybe month or two, it was really like, here's a bunch of code, here's an existing process, here's a star schema, like you need to learn this. And then like, I'm going to ask you to like pull a few metrics around that and maybe start to learn the ropes, right? Because like if you get into a big company, there's a ton of data. But then, yeah, you'll get. I was still brought into meetings, but I wasn't expected to really interact or like provide value. But within a few weeks or months, you start to gain ownership over these projects. Like I was very happy that I wasn't completely thrown into the water and expected to swim. It was kind of like, yeah, we're going to start you off like a couple feet offshore, doing a very laser focused technical task. But then within a few weeks or months, you'll start dog paddling or floating. And then eventually you'll be expected to kind of, swim pretty fast, I guess.
This is actually one of the things that like really concerns me about the trajectory of data science is that when I was, a senior data scientist, I did scope things with the business. I'd go on tour to get buy-in and try and get people to behind the idea of, a problem I was working on. And then I was the head of data science at another company. And there's sort of been this rise of project managers and this idea that data scientists aren't great with the business. So we're going to let them focus on the tech stuff. And I'm not talking about for like really entry level, but like this sort of struck a, because you are going to get to a point in your career where you are going to want to interface with the business. You are going to want to be able to have those conversations, because not only that, but the project managers typically don't have the technical ability to fully scope a project. So what you end up with is a game of telephone, and then there ends up being this back and forth because, they don't know what the different intricacies of the different models and the different options are. And so then there's information left off, and it can be difficult. And so, I think in the beginning, you're sort of, you already talked about this, and then hopefully they take the training wheels off. Hopefully you get an opportunity to interface with the business.
Yeah.
If you get into a place where you are expected to like just be in a little shop and like stare at your computer and you're not getting that business experience, you need to go get it someplace else, because it'll hurt your career.
No, it was so cool. Like my first job, like I've been in positions like that where you just felt like a number monkey. Like you're just like, go sit in the corner and give us the stuff. And it's like, well, you don't even know what you want or to ask for. Yes. But and others, like at Liberty, when I was optimizing call centers, they would send me to the call center and I just watch what a call center agent does, because they want me to, like, my models are impacting what's popping up on the screen. And we had some amazing people. When you find that amazing stakeholder, you learn so much more and you're so much more effective at your job. And they're so happy to, like, tell you what they're seeing that you're not doing right, or like, hey, we need to tweak this. But you're also able to give them immense value and feedback, and like you get that partnership. It's amazing. But when you do find yourself siloed, oh man, it's just like, that's when I'm looking for a new job. Usually it's like, what's the point? Like, I don't care.
Yeah, no, stakeholders want you to care and love, like be excited about their project, and it makes such a difference. Okay. Is there scope for non-tech individuals? And then this will be maybe the last question, because it is 1 o'clock, but is there scope for non-tech individuals? I see in the job descriptions, they always want a master's, PhD in comp science or mathematics. What is your perspective on this, please?
Yeah, I mean, in my experience, I've definitely seen this. I mean, I taught at a boot camp. Plenty of people without masters or PhDs were getting jobs in data science. Mm-hmm. I think that these requirements sort of scale with the overall market, though. So it's like in a boom that we saw, like the late teens and then early 2020s. Companies are going to be a little bit more open-minded. Because all the PhDs are getting sucked up. Like they're like, everyone has already hired, all the PhDs are already accounted for, and we still need more people in this role. So I will say, like, yeah, quite candidly, it will be harder when the market's a little bit, less of a hiring market, like we saw in the last year or two. But there's always an avenue for people. But like I said earlier, there's going to be doors that are closed to you. Which does make it a little bit harder, which just increases the importance of networking portfolios. And like I said, you might end up finding a company that you really think does awesome stuff with data as an analyst, and then see if you can work internally while you continue to build your skills and maybe get some mentorship there. But there's like multiple paths where these barriers don't exist. But the worst sort of gatekeeping is when you are an outsider and you're looking at a job on LinkedIn, which has 200 applicants. That's a very difficult bridge to cross a lot of the time.
One exception being, so like Andrew Madsen talked about on a recent episode, his original experience was in compliance. So then when he went to go into data, there were people who understood deeply that domain, right? And so it's less so with, it doesn't work for all domains, but if you're doing something like compliance or some of the more niche domains where like, the models that you're going to build may be specific to having domain context, then it can work in your favor.
No, that's a great point. Like in our boot camp, like some of the people that got hired quickest was like, we had a doctor or someone who was a nurse, and they went into healthcare data science, or like finance. And it's like, I'm upskilling. I understand, like, it's harder to teach the domain expertise of finance than it is to teach somebody like how to build predictive models a lot of the time, especially if there's like political inner workings of the industry, or, compliance, like you said. And so in those situations too, having like a deep area of subject matter expertise is an awesome path for sure.
All right. So we do have to end it there. Chris, thank you so much. This was so much fun. I feel fired up.
Could talk for hours.
Right. Thank you everyone for joining. I hope you had as much fun as I did. Thank you again, Chris. And I hope to see you all again next week.
See ya.